So in this video, let's talk about how to draw the lowest structure of OF2, right? So how do we draw the lowest structure of oxygen difluoride? Well, the first thing I'm going to do is I'm going to write down my atoms and how much of them I have. Now, from the periodic table, we should know by now that oxygen gives us 6 valence electrons and fluorine gives us 7 valence electrons. So the idea is I want to count up the total number of valence electrons I have to place. So in this case, because I have 2 fluorine, each worth 7 valence electrons apiece, so that means this is 2 times 7, which is 14, and I add 6, right, because of the oxygen. So this would be a total of 20 electrons that I have to place. Now, usually, as expected, the atom furthest to the left, or the first atom in the molecular form, is usually your central atom, right? So I essentially have an oxygen surrounded by 2 fluorines. Now, because I want to start off by placing the lowest amount of electrons, I could just start off by forming single bonds, right? This would be the least expensive method, so I'm not overworking my problem, or I'm not underworking. I'm starting from the base and then I'm building up. Now at this point we've used 4. We've only used 4 valence electrons out of the 20 that we had to place. And we know that oxygen is one of those molecules that has to satisfy the octet rule. So do fluorine. So we need to find a way to put together 20 electrons in the molecular formula that satisfy both oxygen's octet and the fluorine's octet, and giving us 20 electrons total. Now at this point, since I have 4 electrons around the oxygen, I'm going to go ahead and form and put 2 lone pairs around the oxygen, and let's see what that do. In this case, it becomes 2, 4, 6, 8. So this oxygen is satisfied. Now, what about the fluorines? The fluorines only have 2 valence electrons around them. Now, because oxygen's octet is satisfied, I cannot put any more electrons around the oxygen. So that means I can't form a double bond or a triple bond with respect to the fluorine oxygen space. Right, so the only thing I could do is then do lone pairs around my fluorines. So in this case, I could do 3 sets of lone pairs, and I could do it on the same side, right? We're in the same space, so this becomes 2, 4, 6, 8. So this fluorine is satisfied, and this becomes 2, 4, 6, 8. So this fluorine is satisfied. Now let's count up the total number of electrons we've placed. So this becomes 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right, so we've placed 20 electrons, and this is actually a plausible lowest structure for the OF2 molecule.